The objectives of this example are to show 8-bit addition, discuss signed versus unsigned arithmetic operations, and consider the important problem of overflow errors. Let's begin. The goal of this problem is to write assembly code that calculates N+10 and stores the sum into another variable called M. In C, we would define 8-bit variables with the char, and this would make them signed. However, if we added the unsigned to the definition, then the two 8-bit variables would be unsigned. To solve this problem in assembly, we will first bring one of the numbers into a register. We will perform the operation on that first number, in this case adding 10, and thirdly we will store the result back into the variable. Again, the first step is to bring n into a register. We have chosen register A because it's 8 bits and matches the size of the variable n. The load A instruction will copy the value of n into register A. The second step will be to add the constant 10 to the register A. When we choose the add A instruction, we're choosing register A again because it's 8 bits, but we did not specify whether the number was signed or unsigned. The add instruction in this case works for both signed and unsigned numbers. And the last step is to store the result into the variable m. Let's consider the problem of overflow. If we add an 8-bit number to another 8-bit numbers, we will get a 9-bit result. In this case, we stored the result back into an 8-bit variable, and therefore we had the possibility of getting the wrong answer. There are 4 condition codes which are set after the add instruction. The z-bit is set if the result were 0. The n-bit were set if the result is negative, or in particular if bit 7 is set. And then we have 2 overflow bits. The carry bit, which is an unsigned overflow, occurs if the 2 numbers were unsigned and the result is incorrect. And the v-bit is set on a signed overflow. Let's review. If n and m are unsigned, in C we would have placed the unsigned specification here in the definition. If m and n are unsigned, then their values exist from 0 to 255. And the C bit will be set if n+10 is greater than 255, meaning the result that we've stored into m is incorrect. On the other hand, if m and n are signed numbers, they exist from -128 to +127. And the v-bit will be set if n+10 is less than -128, or if n+10 is greater than 127. Again, the v-bit is set if the error is incorrect. What do we do with this? In assembly language, we have the option of testing the carry bit after an unsigned add. So, after we add 10, we could branch if the carry is set to some sort of error condition. Again, we will be at the error condition if the result would have been incorrect. On the other hand, if n and m were signed, we could then use the branch on v set, branch on the v-bit being set to the error condition. So, in summary, we saw we had an 8-bit addition, and we used an 8-bit register. Second, we saw that the numbers could have been signed, and that meant -128 to +127, or unsigned, 0 to 255. And how we used this information was to determine or to specify which bit do we check for an error. Again, we'll check the C bit on error for unsigned math, and we'll check the V bit on error for signed math. Thank you very much.